Hey there, everyone. Today's lesson is on 7.3.2. We're going to be looking at equations that aren't necessarily in standard form and how to graph them when they're hyperbolas. So a lot of what we're about to do is the same as when you're trying to solve for ellipses. You're still going to be completing the square. You're going to try and get all of your terms into binomials. So if we have this equation, 25x squared minus 16y squared plus 100x plus 96y equals 444, we want to put our like terms together, so I'm going to reorder this so that I have 25x squared plus 100x minus 16y squared plus 96y equals 444, and they put that over there for us already, so that's nice. But I need to complete the square, and the easiest way to do that is to factor out. So I'm going to factor out a 25 from this one. So it leaves me with x squared plus 4x. And then I can complete the square inside the parentheses. And then for this one I'm going to factor out negative 16. So this becomes y squared minus 16 goes into 96 6 times. So this is 6y. Just be careful with your negative sign there. Right, you're factoring out a negative from both terms. So you need to make sure that you change the sign to a negative there. And now we're going to complete the square. So half of 4 is 2, and 2 squared is 4. So I'm going to add 4 there, which means I need to add 4 times 25. So it's going to be plus 100. And then half of negative 6 is negative 3, and negative 3 squared is 9, so I'm going to add 9 here. 9 times 16 is 144, so I'm going to, and that's a negative. Negative 16 times 9 is negative 144, so minus 144. And then we can go ahead and factor these. So x squared plus 4x plus 4 factors to be x plus 2 squared. And I still have my 25 out front. Minus, this is 16 times y minus 3 squared. Well, this is equal to, let's see, if we subtract 144, it's going to be 300. Plus 100 is 400. Okay, so big numbers, but watch what happens here. We're going to set this equal to 1, so we divide everything by 400. This should seem pretty familiar. It's kind of the same process that you do with putting ellipses into standard form. This reduces, 25 goes into 400 16 times, so this is x plus 2 squared over 16. Minus, that's the main difference here, is that we're subtracting now. 16 goes into 400 25 times. And now it's equal to 1. And now you have your standard form. So we can go ahead and graph this now. Let's go ahead and identify our center. Center is at hk. You can see that h is negative 2. K is 3. A squared is equal to the first one, not the largest one. So A is 16. A squared is 16. B squared is 25. Which means A is 4, B is 5. And if we wanted to solve for the focus, we would do A squared plus B squared and then square root it. So we'd see that C squared is going to equal 41. So C equals the square root of 41. Alright, we're ready to graph this now. So I'm going to start with my center. It's always a good place to start. At negative 2, 3, there's the center of my hyperbola. This is a horizontal one because I start with the x minus 2 or x plus 2 squared term, so this is going to be horizontal. So I know to go 4 units to the right to find my vertex. Remember, a is always the distance from the center to the vertex, so 1, 2, 3, 4. 1, 2, 3, 4. And then I need to find my asymptotes. So I'm going to create a rectangle. Okay, that's 2 A's long and 2 B's wide, so I'm going to go 5 units above 1, 2, 3, 4, 5, way up here, down here, down here. And then I can construct a little rectangle that'll help me guide my asymptotes when I draw this hyperbola. There we go. And if I want to plot the foci, they're C away from the center. So square root of 41, that's approximately 6.4, I believe. Close enough. So we're going to go 6 units, 1, 2, 3, 4, 5, 6, and a little bit more. There's my foci here and here. Going to have to roughly estimate it because it's not an exact number. Let's go ahead and plot our asymptotes. There's one. Here's the other. And I'll extend them a little bit because we want to be able to use them as a guide. Okay, and now we're ready to plot our actual hyperbola curves. Remember, they go through the vertex, not the focus. There you go. And there. Okay. So try one on your own. Okay, so here's the completed solution. It was a little different from the first one because there was no y to complete the square with. You just had y squared. So all you had to do is rewrite it as -3 times parentheses y minus 0 squared. So just inject that 0 for your k, and then it'll be pretty apparent where the center is. So the center was at 3, 0. So you go 3 units to the right and 0. There's your center. From that point, you're going to find your a, b, and c. If you put it in the correct standard form, you should have gotten that a was the square root of 27, or about 5.2. B square root of 18, and c, when you solved that, would be square root of 45. So I went and plotted my foci. They were 6.7 units out, and I drew my rectangle so that I could get my asymptotes. Okay. Let's go on to the next example. Sometimes it'll just give you the characteristics of the hyperbola and want you to write the equation. So again, very similar to when we had ellipses. If you need to, you can graph these coordinates, but if you use your midpoint formula or just some general logic, you should be able to find out a lot of the things without graphing them. So the first thing I noticed is that you give me the vertices for letter A, which means if I could find the midpoint, that would tell me where the center is, and that'll give me h and k for my formula. So -3, -6, and -3, 2, if I use the midpoint formula, I'll find out that the center is going to be at the average of the x-coordinates, so that's -3 plus -3 divided by 2, and the average of the y-coordinates, so -6 plus 2 divided by 2. That first coordinate's not going to change, it's -3, and then this one's going to be at -2. So there's my center. If I find the distance from the center to the vertex, that will tell me what A is. You can pick either vertex that would be 4 units away from both of them, so A is going to be 4. B, we're not going to be able to find B unless we use our formula, so I need to figure out what C is first. C is going to equal the distance from the center to the foci, so -3, -2, that's 5 units away from -3, -7, so C is going to be 5. And then we can use a squared plus b squared equals c squared to get b. You're going to see that b is equal to 3. It's a 3, 4, 5 triangle right there. So now that we know that a is 4, b is 3, and c is 5, we can write our equation. Because I know that my vertices are -3, -6, and -3, 2, it's a vertical hyperbola, right? These vertices are at the same x-coordinate but different y-coordinates, so it's going vertical. So I know to use this equation, y minus k squared over a squared. A always goes first in hyperbolas, minus x minus h squared over b squared equals 1. We'll plug in h, k, a, and b. This is going to be y plus 2 squared, right? Negative x over a squared is 16 minus x plus 3 let's see if my pen will work. There we go. Plus 3 squared over b squared, which is 9, equals 1. So that is our solution. Okay, let's see if they give you a different type of characteristics. What if they gave you the asymptotes and the vertices? Okay, so the first thing we need to do, again, is find your center. The center is going to be the midpoint between these vertices. So my center would be at the average of their x-coordinates. So -3 plus -9 divided by 2, and 0 plus 0 divided by 2. It's going to give me the center at -6, 0, which is going to tell me h and k. And I can actually solve for a if I find the distance from the center to one of the vertices. So I notice that -6 is 3 units away from -9, so a is going to equal 3. Okay, but now I need to either find b or c. I don't know anything about the foci, but I do know the asymptotes. And the asymptotes are supposed to have a slope that would equal either b plus or minus b over a, or plus or minus a over b. It depends which type of hyperbola you have. So I need to look at the vertices and see which way they're aligned. They have different x values, so it's going to be a horizontal ellipse, or sorry, horizontal hyperbola. So the horizontal hyperbola means that I'm going to go up b and over a. So this one is the slope that you use for horizontal. This one would be the one you would use for vertical. Okay, and I can see in my asymptotes that they both have a slope of 2 or -2. They should be opposites. So I'm just going to use 2 to solve this one. And I know that it's going to be b over a. So when I plug in 3 for a, I can solve that b is equal to 6. And you can solve for the positive or the negative, because when you plug it into the equation, you're going to square b anyway. So now we have a, b, and our center. We really don't need c to write the equation, so I'm going to use my horizontal x minus h squared over a squared minus y minus k squared over b squared is equal to 1. And we're just going to pop in all these numbers. This is x plus 6 squared over a squared, which is 9, minus y minus 0. So it's just going to be y squared over b squared, which is 36, equals 1. Okay, be very careful about the order for x and y. It's dependent upon whether the hyperbola is described as being horizontal or vertical. Okay, try these two on your own. Okay, those are the solutions for these two problems. A couple of different tricks that you may have, or problems you may have come across. This one describes the conjugate axis. Remember, the conjugate axis is actually twice the length of your b. So even though they didn't give you the foci, they told you what b was, because if you know the conjugate axis is 10, it's kind of like your minor axis. It's going to describe b. So you just take half of 10 to get that b is 5. And we know that this is a vertical because the vertices are changing vertically. Their y-coordinates change. So you make sure you use y minus k squared over a squared minus x minus h squared over b squared. Just plug in a and b and your center, which you got as the midpoint, and you're done with that one. And then for b, they give you the foci and the asymptotes. The asymptotes were to help you find b and a. Since b over a was 3 over 4, and the distance from the center to the foci was 5, you saw that it had to be a 3, 4, 5 ratio, which pretty much locked a and b as being 4 and 3. You know a is the 4 below, because in a horizontal hyperbola, you use b divided by a. So once you solve for a and b, you just plug them into the standard form. That's it for 7.3.2.